Welcome to qnawire.
Here in this question we are given wall temperature TB is equal to 100 degree Celsius. The fluid temperature T infinity is equal to 20 degree Celsius. Heat transfer coefficient H is equal to 75 watt per meter square Kelvin. Fin thickness is given, which is 6 mm, and here length L is given, which is 20 mm. So this is the first case we are going to solve. Here in the first case the thickness is 6 mm and length L is equal to 20 mm. So here we need to calculate the efficiency of fin, represented as eta of fin is equal to, the equation is tan h of ml divided by ml. Here L is equal to length of fin plus thickness by 2. It becomes, here the length of the fin is 20 mm plus thickness is 6 mm, so 6 by 2. Converting it into meter, we have to divide it by 1000. Upon solving, we will get a L is equal to 0.023 meter. And here in this case, the value of m is equal to square root of 2h divided by k into t. Here k represents thermal conductivity, and the thermal conductivity value is 16.2 watt per meter Kelvin for steel 304 grade. This is the value of K. Therefore, M is equal to square root of 2 into value of H is 75 divided by K is 16.2 into thickness, which is 6 by 1000 meter. Upon solving, we will get value of M is equal to 39.28. So here we have already found out the value of L as well as value of M here. Now here we need to calculate the efficiency of the fin. Eta of fin is equal to tan h of M into L. Here value of M is 39.28 into the value of L is 0.023 divided by M into L. Upon solving, we will get a efficiency of fin to be 0.794, or in percentage it becomes 79.4 percentage. So here in the first case the efficiency is 79.4 percentage. Now here in the first case we need to calculate heat transfer loss per unit width. The equation for heat transfer loss per unit width is given by Q of fin is equal to efficiency of the fin into H into area of the fin into the temperature difference, that is wall temperature minus T infinity. Substituting the values, here the efficiency is 0.794 into value of H is 75 into here area is 2 into 0.023 into the temperature difference, which is 100 degrees Celsius minus 20 degrees Celsius. Upon solving, we will get a heat transfer loss per unit width to be 219.14 watts. So this is the value of heat transfer loss per unit width. Now we are moving on to the next case, case 2. Here we are considering thickness of fin is equal to 10 mm and length is the same above, which is 20 mm. So here in the first case we need to calculate the efficiency of fin. The equation is tan h of m into L divided by m into L. Here L is equal to the length 20 plus thickness which is 10 mm by 2 whole divided by 1000. Upon solving we will get a L is equal to 0.025 meter, and here M is equal to square root of 2 into H is 75 divided by K into T. Here K is 16.2 into thickness is 10 mm, that is 0.01 meter. Upon solving we will get a value of M to be 30.43. So this is the value of L and M here. Substituting the values, efficiency becomes tan H into M, which is 30.43 into L, which is 0.025 divided by 30.43 into 0.025. Upon solving we will get a efficiency value to be 0.8435, or this is equal to 84.35% is the value of efficiency when thickness is equal to 10 mm. Now here we need to calculate heat transfer loss per unit width when thickness T is equal to 10 mm. Here the equation is heat transfer loss of the fin is equal to efficiency of the fin into H into area of the fin into the temperature difference. Substituting the values, here efficiency is equal to 0.8435 into H is 75 into area will be 2 into 0.025 into the temperature difference, which is 100 minus 20. Upon solving we will get a heat transfer loss per unit width to be 253 watts. So this will be the final answer of this question.